The ideas expressed in the following presentations are those of the speakers and do not necessarily reflect the views of ACI or its committees. ACI web sessions are recorded at ACI conventions or other concrete industry events and will be made available for viewing free of charge for 1 week. Thereafter, they will be archived on the ACI website or added to ACI's online CEU program, depending on their content.
Thank you, Kevin. Good morning, everyone. Repair and rehabilitation projects, for those, I'm sure there's people in the room who work in that arena, the responsibility lines can be quite different. And it's been our experience and my experience personally for the projects to be successful. So my presentation today is to give you some specific examples of projects in the 3 phases that projects typically happen: in the evaluation phase, in the repair design phase, and then in the construction phase. And reference certain documents that talk about responsibilities and give you examples of how we've encountered situations and how we've stepped over the boundaries of normal responsibility that I learned personally when I was a young engineer learning how to design new building construction. Give you a little bit of background on Committee 132. I'm a new member of that. Kevin is the chair of that committee. And that committee began several years back as a board committee, and it was charged at that point in time to begin defining roles and responsibilities. They produced their first guideline on the authorities and responsibilities that was actually published in Concrete International in 2005. They were not a board committee, or I guess it wasn't a long-lived situation as a board committee. They then became a technical committee because they had an important message to get out there. So they ultimately did publish a formal guide document on the responsibilities in concrete construction. A very important document, but it addresses the responsibilities in new concrete construction, which are significantly different. So one of the things the committee is looking at doing now is to either create an additional guide or an appendix to really address the differences in the repair rehabilitation industry. A little bit more background, I'm going to reference a very important document through good portions of the presentation this morning on the ACI 562. It's the code requirements for assessment, repair, rehabilitation of existing concrete structures. This is a new repair code that's in the process of being adopted officially throughout the country. Just so, hopefully everybody in the room is familiar with this, but the intent of this code is, you're all familiar with 318. Once a building is built and has a certificate of occupancy, the expectation is 318 is no longer applicable to that building. 562 comes into play. So any alterations, repair, renovations that happen to that building really get governed by 562 in the future. And as with 318, 301 is the specification that goes along with it. There's a document that hopefully will be published within the next year. 563, which is the specifications, the instructions to the contractor for repair. So we'll talk about the first facet of any repair projects. They always begin with an evaluation. And evaluations are done for a number of reasons. Whether an owner wants to change the use of the building, there's deterioration, distress in the building structure, there's damage that happens, whether it's by fire or a natural event, hurricane or a storm, or even just a transaction, an owner selling the building and a new owner is taking on that building. So there's a lot of reasons to perform evaluations. Just so you know, I know Keith's not here, but I tend to use the term evaluation and assessment interchangeably. I know they're not. They changed the title of the code from evaluation to assessment, but I'll use them interchangeably, so pardon my taking that liberty. There are a number of guidelines out there that help understand and are very useful when performing evaluations of buildings. ACI 364 has a guide document, evaluation of concrete structures before rehabilitation. ASCE has 2 relevant documents, and these are just a couple that are listed. The ASTM one talks about doing due diligence level assessments. The Japan Concrete Institute has a recently published document that's very extensive, it's a very good document. And then the last one on the list there is the one that everybody's familiar now with, facade inspection ordinances. And there's other documents out there. The thing about these documents, they're very good at talking about the process for forming evaluations. They talk different levels of evaluation, whether they're detailed, preliminary. In some cases, on the due diligence, but they give you a lot of instruction in that regard. When it comes down to the standard of care, and when it comes down to the responsibility of a design professional performing that work, there's a lot to be desired. There's certainly room for improvement. But let me give you some examples of how they do address that. The first one there, the Japan Concrete Institute actually defines they use the term responsible engineer. They're really talking about the qualifications of the person performing that evaluation. Where these guides get far more specific about responsibilities typically is when you're going to deal with unsafe conditions. So this is an excerpt from one of the ASCE guides, and I've highlighted that area in red. Whenever you're dealing with unsafe conditions that are discovered, you have a professional responsibility to do something about it. Typically it's to notify the proper party and then to see that it's remediated or to protect the public. Facade ordinances, they've been around in some jurisdictions for quite some time, but I know in Philadelphia here they only adopted theirs probably about 6 or 8 years ago. This is actually an excerpt from their ordinance. And again, I've emphasized some of these areas or highlighted some of these areas. So they talk about an appropriate professional standard of care to detect distress conditions. When you undertake a facade ordinance inspection, you're specifically looking for conditions that could be a hazard. And presumably, if and when you do discover it, you've got an obligation to report that. In Philadelphia, you see an obligation within 12 hours of encountering that condition. So these guidelines are beginning to get far more definitive on the responsibility. Again, going back to what 132 is trying to do is to fill in the gaps and provide more information. That's what we're hoping comes out of presentations like this and the special publication. So now let's give you some specific examples where I'll talk about responsibility during the evaluation period, some of the things that were considered that seem to make a lot of sense, and some of the things that perhaps weren't considered too well. It's an overview on the left-hand side of an aging parking structure. It's in the northeastern United States. It happens to be serving a healthcare facility. The interesting thing, I think this is 30, 40 years old. It was an unbonded post-tension system, still is, it's still there. The photo on the right, I apologize, it's a copy of a photograph, so it didn't come out too awfully well. But what was very apparent, back up a little bit more, they had a condition assessment done by an engineer that told them they had problems, that the post-tensioning system was failing. That evaluation was several months old. When I was asked to look at it, they were getting proposals from several engineering firms. What I thought was interesting was their prior report that they had been given gave them some indication that they had issues, that they should take precautions when they had tendon anchors sticking out of the end of the deck like this. And for those of you who hopefully are familiar with what these tendon anchors look like, this is a couple of them more close up. So you can see the tendon's obviously ruptured. You see the grout pocket is still stuck on the end of the tendon anchor. They had given them some recommendations to not park in certain areas of the deck. So, good thing. I was kind of surprised that it had been several months since they had this report and they hadn't done more. But probably the thing that was more disconcerting to me was there were probably 24 tendon anchors sticking out of the perimeter of the building, the perimeter of the garage as it walked around it. So it wasn't just a couple of tendons. So obviously there's a concern. You want to tell the owner of the parking structure that there's probably an impact on the load carrying capacity of the garage with these amount of tendon anchors. The thing that's not really apparent though is that right across the street is residential homes. This building was surrounded on 3 sides by row homes like that. And I don't know if you've ever seen anchors, whether they're cut accidentally or they break accidentally. There's a lot of energy released when an anchor goes. You see some of these are still intact right here. They don't all have grout pockets on them. It's not uncommon when anchors break that grout pocket is shot across the street. So again, we talk a little bit about a standard of care and how you really have to have a far better sense. When you're looking at structures and distressed structures, you really should have a pretty good understanding of what type of structure you're dealing with and consider these things. If you were here in the morning session, you saw a different vantage point on this photo. You just see things in structures sometimes, I don't know. I've seen enough of them, I laugh a little bit. That shim stack was in there when they built this garage. This garage was 15 years old, at least when we walked through it. But if you know anything about precast pre-stressed structures and T's, they tend to move up and down, and the bearings move over time. There's a certain amount of movement that happens. And so you see, I guess in the right-hand shot, looking at that close, that shim stack's about ready to fall out. If you were here in the morning, you saw a picture that Keith Kessner had where we actually jacked that back up slightly, pushed the shim stack back in it, and stabilized it so it wouldn't come out again. But facade ordinance inspections, I mentioned this for a couple of points I want to make in this case. When an engineer undertakes an ordinance inspection of a building, they really should be prepared to not only discover unsafe conditions, but to potentially be in a position to do something about the unsafe conditions. We were asked to look at this building. It was very apparent. This is a limestone building, limestone clad building, but concrete, precast clad buildings could have the same types of problems where you see that halo on the right-hand side. They're obviously distress from the anchors that were causing these fragments to pop off. This is a relatively new building. When an engineer gets into a situation like this, our policy is not to just tell them they have a problem and go to the local authority and report the unsafe condition. But typically what we'll do is before we even get into a project like this, say when we're proposing on it, we're going to include some level of access to get up close and look at it, to investigate it sufficiently, whether that's renting a high reach or putting a swing stage on a building. We're usually engaging a contractor. In a situation like this, we actually have a contractor on board with us that helps us facilitate and do the inspection. And then we tell the owner at that point in time, here's some idea on how you can remediate this condition, and we're ready to remediate it as step 2. Some engineers are very squeamish about getting into a situation where they're on the building with the contractor, directing them firsthand to stabilize the situation, and then make a statement at the end of that it's safe. I'm not sure if you've ever been in that situation before, but another thing that was not obvious to this, just point out, you're seeing the pop-outs on the outside of the panels. There was at least as many that didn't fail on the outside that failed to the inside of this. The contractor that built this put expansive grout in because it set real fast. So again, the immediate life safety hazard is that these little shards are going to fall off the top. Believe me, they would cause a problem. But once you realize that there were far more failures on the inside as well, the sealant was the only thing holding some of these panels up on the building. So the problems can be far more significant than what's just immediately apparent when you first see it. I put this up here, due diligence assessments. We don't do a lot of due diligence assessments, but there can be some real significant concerns when you're in that situation. Number one, if you discover an unsafe condition while you're doing a due diligence assessment. By due diligence, I mean, say during a transaction, you're working for a potential buyer of a building. You see a condition in the building that really is unsafe. You're not working for the owner. Who do you report that condition to? What authority do you have to report that condition to a local authority? What you report on that probably will have an impact on that transaction. So I don't know if you do due diligence assessments, but if you do, you just have to consider a lot of the things that you may run across. Right, so now we'll transition a little bit and talk about going from evaluation into repair design. This is a clause out of the 562 code that I think is relevant for what I'm going to show you next. And again, the emphasis is added here. So the adequate temporary shoring and bracing of affected members shall be provided during evaluation and repair construction. It's not uncommon that you see conditions during an evaluation that probably shouldn't be left in that state while you put the repair design together and go out there and repair. Sometimes you have to just jump on it pretty quickly. So let me show you an example of a parking structure that we were asked to look at. It's 3 stories below grade underneath of a research science building. And I'm not sure if this is real clear, but as we're walking into the garage and looking up, for the structural engineers in the audience, you'll see some fun cracking. That's not flexural cracking. These are joists. There's no shear reinforcing in these joists. It's more than a few of them that were cracked like that. Became very concerning and something that we brought to their attention right away. But then as we look further, so what you were looking up at was actually the loading dock. It wasn't even the garage. Here's the doorway and the ramp into the garage. So to get in the garage, you went in and out here. Those joists you were looking at were underneath there. So needless to say, we didn't think that was something that could sit that way for too long. So we spoke to the owner about it. They basically stopped using the loading dock actively to bring trucks in. And within a couple of weeks, we had put together basically a shoring program to go in and shore the affected areas, but yet keep the rest of the garage operational down below. Again, designing new buildings, not a lot of situations where the engineer of record gets involved in shoring. If they do, they delegate it. This needed to happen rather quickly. So we're not too timid about those sorts of things. So we designed a shoring system. We were very specific about what we wanted and how we wanted it installed. And so we prepared documents for it, got proposals, and went out and put it in. So we shored the joists. This is the lower level ramp that you could get under so the garage could stay operational. And really within just a couple of weeks, they had the situation, back, at least it was safe. And it was quite some time afterward that they went and funded the garage repair that they were going to do on the building. But at least it was safe. All right, now into the repair design itself. The design of concrete repairs, there's a lot that goes into that. You've all attended sessions, presumably, on corrosion and assessing a building and understanding the cause of deterioration and distress in it. So there's a lot that goes into that part of it. But there's an awful lot that goes into the design of how are you going to accomplish the work? How are you going to access the areas of the building? It's the false work, the scaffolding. Are you going to constrain the contractor or provide limitations for that? This is a stadium that many of you may be familiar with, doing a quite large concrete restoration program on it. And the first phase of it was scheduled to last an entire year. Well, like most owners, they want to keep their facility operational throughout that period of time. So one of the things we looked at in the very beginning, before the project design was ever completed, was how are we going to stage it? We were going to work on the upper grandstands first. You see it on the upper right-hand side. So that was the main focus area. And the idea, or the two things we looked at is, do we scaffold off the lower grandstand up to the underside of that? If we had scaffolded off these grandstands up, what happened was it would just preclude the use of the grandstands for that entire period of time. This is the Ivy League. They don't fill this stadium for football, but they do fill it for graduation and for certain other programs throughout the year, so that was important. So the challenge for us was to look at, well, how do we scaffold it so that they can accomplish the work, but they still have the stadium mostly accessible during the year. So we had looked at different scaffolding alternatives for that. Again, so I mentioned that means, methods, and sequences of construction. The design professionals in the room are very familiar with that term. Every agency agreement that's out there for design professional services, AAE, EJ, CDC, they specifically say that the design professional is not responsible for means and methods and sequence of construction. And we know why. It directly connects you to safety obligations. However, you really can't do effective repair projects without getting well down that path into it. And this is what 562 talks about. The design professional is responsible for the structural stability, the overall stability of the structure, and all those members during the repair program. So the design professional has to consider how that structure is going to react during the repair program. In our case, we were talking about how's it going to support a suspended scaffold system that was hung from the upper grandstands to basically facilitate the work. So we did a lot of analysis during the design part of the project to basically say, now this is the scaffold shop drawings of the part. So what happens is, and these are the large raker beams that we looked at, and we assessed how can they support the load of the suspended scaffold system, the staging that was on it, the debris that gets taken out, the material that's put in, the equipment that's used during that process. So our obligation as the engineer of record was to make sure the structure could take it, to tell in the delegated design to the scaffold contractor, this is where you can attach. These are the maximum loads you can impose. So this was really the result of their delegated design. And we suspended it across most of it. At the end, we did have to erect some areas where the scaffold was built off the lower grandstand levels. But you'll see everything that has to get considered. The scaffolding in stadium has to consider more than just the equipment and the personnel. It's got to consider wind loads, because we've got the thing completely enshrouded to confine dust and debris and everything else. Again, new construction, engineer record only goes so far in looking at scaffold systems like this. We designed an awful lot of this, and this was actually bid straight to a scaffold contractor, and they were brought on directly by the owner. That really, they had no relationship with the concrete repair contractor at the end of the day. Parking garages is something that we like to do. Just about every owner you run across, when they do get into a repair program, the last thing they want to do is to close the garage. It's a revenue-producing facility for them. So the challenge is really, how can you effectively get the work done by minimizing the amount of spaces that are lost in the garage? So you're into the sequences automatically. You're looking at how do you concentrate work areas to maximize the productivity of the contractor, while at the same time allowing vehicles to drive in and around that area, allowing people to safely park in the facility. So you get into the parking logistics of it. But then there's another significant part that you always inevitably get into. And so we look at another clause in 562. So the design, assuring, and bracing members, in the assessment has to be based on the existing cross sections present in the structure that you're dealing with. When you're working on a parking garage, in this case, we work on typically a floor at a time, so we can minimize the amount of parking that's taken out of service. So we'll close off an area below to make it safe. We have an area that we're working on, but inevitably you're carrying on operations and potentially shoring on parts of the structure that have not been fixed yet. So you've got to go through and carefully look at the distress and deterioration that exists, rationally make some determination of what's the capacity of that, if you're going to, particularly if you're going to put shoring on it. In this case, it was an unbonded, post-tensioned facility. The challenge to putting shoring in it would have really impacted the parking tremendously. And there were a number of failed tendons in it. So this next slide is actually, this is the one that just shows the kind of the sequencing so you understand it. This is kind of how we would work on a typical floor level of it, typical double helix. So we would be working on a level here. We've got it barricaded around to protect the workers and keep people segregated. We've protected the area below. So we've taken these parking out of service. We're redirecting traffic. You have the whole traffic logistical side of it. Just focus on the lower left-hand side of this. So this is the plan that shows all the tendons in the deck. And we've gone through, done a lot of diagnostic work, a lot of non-destructive testing, and a certain amount of tendon testing and surgery on it to find the tendons and look at the condition. But ultimately, in this segment of the garage, everything in blue were the tendons that we anticipated cutting, splicing, and refeeding back in. So, and this, it varied from floor to floor. So the one challenge was, how to back up a little bit. Our attitude towards this was we didn't want to give the contractor the latitude to figure out how many tendons they could cut at any given time for the garage to remain safe for them to work on it. So we actually told them, you can only take so many tendons out at a time, splice them, re-stress them, put the strength back into the deck before you move on to the next level. So even though we would close half the deck, you know, one way to do it, the contractor might do it, they might whack all the tendons at once and do it. We didn't give them that latitude. We said you can take so many out at a time. We felt the deck was still safe at that point in time. Again, we're so far into the sequence of things and constraining the contractor in that regard. But we just find that's the way to successfully do it. If we had given that to the contractor, we just, not that they're not smart, not that they can't figure those things out, but we just feel that that's too much stuff to delegate to them. You lose too much control. All right, so we move on to the construction side of things where it really gets to be a lot more fun. Quick example for you. This is a rather unique one because there were 4 engineering firms involved in this program. Existing building, 40 plus years old, high rise. They discovered a problem one day. It was not an insignificant problem. You see, there was some interesting transfer stuff that happened down around this level of the building. So if you go on the other side of the building, a couple columns come down and get completely transferred out where there's a big plaza level. Contractor was working on it, found some really nasty cracking in the transfer girders. It had been there for quite some time. Brought that to the attention of the engineer for the building. Not the original engineer, but the engineer who, you know, had done a lot of work in the building, was familiar with the building. They looked at it and said, we need to shore this thing. Then we need to figure out how to reinforce it to take care of that. So you have the engineer record who went out and sought out a shoring contractor to put shoring in place for that, and then to figure out how to reinforce it. In this case, the engineer for the building wanted to jack it back up. A lot of challenges. So just trying to illustrate for you what was happening. This is a cutaway of the inside. So you have the 37th floors up here. This is the 6th floor where the transfer girder happened. Ultimately, we figured out that this girder failed. It was severely under-reinforced. It failed as they were building the building. Somewhere up around the 8th or the 10th floor, it had gotten enough load on it that it failed. It didn't just happen. So it was the engineer for the building had done that analysis and kind of gotten satisfied at that level. I'd say the real challenge for us was that they said, we want to push that girder back up. So how far are you going to push it back up? What's the force you're pushing back up? What's going to happen when you push up here? What happens in all these adjacent bays over there? We had a lot of conversation. So our role in it, we were actually brought in by the steel contractor. I'm sorry, a shoring contractor. We were brought in by the shoring contractor. Our role was to figure out how to shore it and to jack it back up. And they had another engineer who was going to design and be responsible for, ultimately they put an external post-tensioning system on it. So that was the third engineer. And rightly so, they went out and got a peer review engineer to look at the thing and say, are we all crazy for what we're going to try and do here? Challenging project. It actually worked very well because the lines of communication, because you had engineers that were very respectful of each other, that were experienced, and we had a lot of open dialogue back and forth in communicating what were the challenges. You can see if anybody's ever tried to do something like that before. You don't run across these too often. No small undertaking. To give you a sense of the scale of that, this is the truss we put into place. There were 3 of these. This is false work. This is a complete open drop 4 stories down below that. So they rigged all that stuff, and that's the truss that we put in place and jacked up off of. It's fun. You don't run across those too often. So back in the real world of how we commonly run across jacking things, anybody's work on precast, pre-stressed garages, it's not uncommon. The garage has been there for a while. There's problems with the bearing pads, so you've got to jack them up and get the bearing pads out. We personally don't think it's wise to let the contractor figure out how to jack and undertake that operation. There's a lot of connections. The camber clip connections here. There's connections that hold the T's to the ends of the spandrel beams. We just don't think it's too wise to give them the latitude to figure out how to jack it up. So in this case, what we do is we typically always will jack up these 2 stems, causes the least amount of distress to the camber clips. This garage was unique. This garage was probably 35, 40 years old. Most of these connections were all broken already. The garage was very happy and free and moving around a lot. So we weren't too worried about these. But we gave them this sequence. We said, you know, no uncertain terms, this is how you will jack it up. This is how you will replace the pads. And there's things you just have to anticipate. Maybe like a lot of garages, the T-stems line up from floor to floor. It didn't in one case, so you can't take for granted. So, like we tried to bring the load down on the T-stem below. It's not easy to analyze what's the capacity of the T-stem below, but you can make some rationale on that. But in this case, it didn't. So we actually had to put extra shorts in there. It's a good thing somebody looked. Just another thing, a quick example. Hydra Demolition on a deck. It was the lower level of a 12-story building. Hydra Demolition is just an awesome way to get concrete out. I don't know if you've ever used it before. But you see the Hydra is all done. We've blown through the deck in numerous places. We had anticipated shoring it to take that all out. We thought we had everything anticipated pretty well, but you still scratch your head at the end. We took so much concrete out here. At the end, we're looking at this and wondering, that's a 2-story column in the bottom of a 12-story building now. And we're doing some serious stuff to its unbraced length. So things just come along that you don't necessarily think about all the time. So that concludes my presentation. Hopefully you've gotten a little bit better sense of some of the things on how those lines are crossed. And it's a wonderful business. We enjoy what we do on the repair rehabilitation side. There's definitely challenges there, but we find a lot of successes come from not being timid and not crossing those lines and just open communication. Thank you again for sitting through the presentation. If you have any questions.